Welcome to your second video in working with trigonometric identities. And in this video we are going to talk about simplifying expressions. And that specifically means that you're going to just break them down. You're going to show each step when you are using, especially when you use your identities. You're going to work vertically, and you must use equal signs when you are simplifying expressions. I know sometimes we don't emphasize that quite enough, but you need to use the equal signs. And you're going to make it a little bit easier. We have all of the problems organized such that you're going to simplify to one term. No fractions. Like, don't leave something 1 over cosine. Write it as secant. So if you're using any of these, you're never going to leave an answer in fraction form. If you get sine over cosine, you write it as tangent. Okay? You never leave a fraction. But it will all simplify to one term. It may be cosine squared, right? It may be a square term, but it will be one term. And in doing so, you've got a lot of tools to do these. You can use any of these identities. Sometimes you'll have to get common denominators. Sometimes you've got to use conjugates. You're going to factor a lot, and recognizing when to factor is also key, because sometimes you don't recognize that if it's to like the 4th power, or because you're not used to seeing the trig functions in that manner. So all of these need to be really, really well known and just at your disposal. So when I do the video, it's going to be a little bit different. I want you to have these items in your notes. So you can take a picture of this, you can put it, just copy those 4 bullets. But for the examples, I'm going to actually just work 4 of your practice problems. And I'm going to work them on the worksheet. If you don't have the worksheet yet or don't have it printed off, then that's fine. You can just work it in your folder, notebook, and then you can write on the worksheet in notes, or you can practice and do it again, which will give you even more practice. So I'm going to do these 4 exercises, and we'll see if it goes in. It probably will go into the second video, but we'll see how long it takes. All right, number 9. So number 9 says 1 plus cosecant over cosine plus cotangent. So when I look at that, I think of a few things first. I try to see, is there anything squared? You know, can I use any of these Pythagorean? No, can't do that. I've got a 1 plus cosecant. Well, cosecant, if I remember from the reciprocal, is 1 over sine. Cotangent, remember, is cosine over sine. So right now, I don't have anything that I can do with any of these terms except take them all back to sine cosine. And that very often is a good tactic. Sometimes it is not needed, however, especially if you can use some of these, okay? But in this case, we need to take it all back to sine cosine. So I'm going to rewrite this as 1 plus cosecant, we said was 1 over sine x, all over cosine, plus, and then cotangent, we learned from the quotient identities, remember, is cosine of x over sine x equals. So I'm working vertically. I'm simplifying this. Well, now I have fraction in the numerator, and I have a fraction in the denominator, so I'm going to need to get a common denominator in each. So I'm going to, here I need a common denominator of sine. So I'm going to have a sine x right there times each of the, or times just this first term. I should not have put that parenthesis there. because I'm just multiplying that by the 1, right? I'm not distributing it. Let's get rid of that. There we go. And then down here, I need to multiply the cosine x by sine x over sine x. And in doing so, I'm multiplying it by 1, so it's no big deal to change that. But then this term becomes sine x becomes sine x over sine x. I have a common denominator, so in my numerator I now have sine x plus 1 over sine x. And that is all over. Down here, my numerator becomes sine cosine plus cosine x all over sine x equals. Now that may look bad, but it actually is coming out very nicely here, because I have a sine x as the new denominator in the numerator, and a sine x as the denominator in the denominator. So when I divide this fraction, those are going to reduce and go away. Also, look right here. I have a cosine x in each of these terms. So I can factor that out. And when I flip it, it's going to be beautiful. Let me show you what happens. So I'm going to rewrite this top fraction as sine x plus 1 over my denominator of sine x. We are going to take the denominator, this fraction, and we're going to multiply by the reciprocal. So I'm going to put sine x here, and then in the denominator I'm going to factor out that cosine. Well, look what happens. If I pull cosine out of here, I've got sine x. If I pull cosine x out of that term, I have a 1. Well, that's beautiful. Look what reduces. The sine x over sine x reduces to 1. Sine x plus 1, I can now cancel with this because they're multiplied. So I have 1 over 1 here times 1 over cosine x. Well, 1 over cosine x is simply secant x. That whole mess went down to just secant x. Isn't that beautiful? So sometimes taking everything back to sine cosine is the way to go. All right, let's look at number 17. 17 says tangent theta times cosecant squared theta minus tangent theta. All right, well, it's similar to what we just did with the cosine. If you determine that you can pull out like terms there, so I can factor out the tangent. Let's see what happens when you pull out a tangent. Here you're going to be left with cosecant squared minus, you factor out a tangent theta, you're going to have 1. Well, look what happens. Cosecant squared minus 1, right here. These need to be known. You need to understand that. And if you have cosecant squared minus 1, you've moved the 1 over here to the right, you're left with cotangent squared. So this equals cotangent squared. Now I'm going to multiply that by my tangent theta. All right? And when you simplify those two, all right, I don't want you just to automatically give me the jump to the answer. You need to show me that you are making this substitution of cotangent squared as 1 over tangent squared. And then you can do this reduction so that you have 1 over tangent theta, which simply is cotangent theta, because remember, you cannot leave any fractions as your answer. You have simplified that expression to one term. All right, let's look at number 20. Number 20 is a fun problem. Number 20 has a sine, a cosine, another sine, 1 plus sine. All right, It already is in sine cosine. There's nothing to take back to sine cosine. We do have a few problems, though, in that I've got these two huge fractions. And I'm not trying to solve this, per se. I need to simplify it. I need to combine the terms. And when we combine fractions that are added and subtracting, we need a common denominator. So, as you can tell, this is probably going to get a little messy. But I need this denominator to be cosine u times 1 plus sine u, and I need this denominator to be 1 plus sine u times the cosine u. So this fraction needs to have a 1 plus sine u, 1 plus sine u. This fraction needs to have the cosine u over cosine u. Because remember, we're multiplying by 1, the same term over itself. So we're not changing the value, we're just changing its form. All right, let's figure this out. I've got 1 plus sine u times 1 plus sine u. Well, those sums, those binomials, when you multiply them out, you have to FOIL that out. So you are going to have, and I'm going to pause this so I can go turn my lights back on. All right, so we've multiplied and distribute this out. We're going to have a 1. The inside term here is going to be sine u, and the outer term will be a positive sine u. So I'm going to have 2 of those sines. The last term will be sine times sine, which will give me a positive sine squared u. Now that is just the numerator of this fraction, minus the denominator over, or the numerator over here, which is cosine u times cosine u, which is cosine squared. And that all is over our newfound common denominator of cosine times 1 plus sine. Now, a little hint. When you have the common denominators in this form where you've got one term and a binomial, do not distribute and multiply that out. And the reason is you're really hoping that this is going to cancel at some point. And if you distribute and multiply that through, then it's a little harder to see. So just leave it alone for right now. Now here is a little trick. You need to combine things in the numerator here. But look at what you have. You've got a 1, a 2, sine u, a sine squared u, minus a cosine squared. Well, here, these need to be added to equal 1. They're subtracted. Okay? However, I can rearrange these. Right? They're all added, they're subtracted. I can rearrange them. So what I'm going to do is I'm going to combine the 1 and the negative cosine squared u. Because 1 minus cosine squared is sine squared. So if I combine both of those, I'm going to write that up here. That is sine squared. So you then have 2 sine u, and you've got 2 of these. 2 sine squared. So 2 sine u plus 2 sine squared. Now, I am going to stop this video, and we will complete this problem in the second video. See you then.